In this video, I'm going to be talking about physics and colliders in p5.play. So I've got this set up here. The p5.play libraries are included. I've got this ball sprite positioned in the center X position and at a Y position of 100, and a box sprite below it. Now, if you've played around with p5 play a bit, you're just starting out, but you've moved some things around the screen. You might have noticed if you've got two objects, and let's say we move this down, this ball down towards the box. If you have two things moving toward each other and they hit each other, they respond as if they were like kind of in this physics simulation. So the first thing to note is that this physics engine is built into p5play by default. So if you create a sprite, it automatically comes with it, a collider, it responds to things when it gets hit, and all the rest. So, but you should also note that the way things collide is determined by something called the collider for each sprite. And you can change the collider for each sprite by changing a property, and that property is appropriately enough called collider. So we can say if we wanted to change the collider of our box sprite, what we do is we say box sprite.collider equals, instead it equals to equal to a string. And there's a there are certain strings that you can use to change how its collider and how it reacts when it gets hit. So first is called dynamic. There's one called kinematic, static, and none. Those are the options that you can pass in that will give you different kinds of reactions when things get hit. So the first being dynamic. Dynamic is what it is by default. So if you set the collider to dynamic, it's the same as if you you didn't set it. And what this does, it means that it just reacts when another physics object hits the box, like the ball, it will react and it will get pushed, like it does in that demo. Another simple one to understand, easy one to understand, is static. So this just means that it won't move. So when it gets hit by something, it doesn't move, and you cannot move it either. So it's always going to be in the same spot, intended to never move and never be pushed. None, also very simple. If you have an object moving towards it, it just doesn't react. It just phases through it. And then the last one, kinematic, is a little bit more subtle to understand. And if we try it out, you can see that it kind of reacts as the static one does. The difference is that you can move it. Now, the best way to think about this is in a video game, you might have moving platforms that move left and right, and the character has to jump on them to get across a pit or something. That would be a great example of using a kinematic collider. Kinematic colliders you can move in code and have them move left and right or up and down, wherever you want to move them, but they're not affected by other physics objects. So like the player doesn't push that platform down when it lands on it. If a boulder hits that platform, it's not going to be affected. That platform will keep on moving. Only the boulder will be affected. So it can affect other physics objects, but it itself doesn't get affected by physics objects. So a good example is like, let's say we wanted to take this box sprite after we set its collider and give it a velocity y of -1 to have it move up. So now you see it's continuing to move up. It doesn't get affected. It doesn't get pushed down by the circle, and which is different from if we change this to dynamic and we try to move it, you can see it does get affected by the ball when it's hit. So that's the difference. You're controlling it via code. It does not react to a force that it gets hit by when it's kinematic. Okay, so I'm going to make this back to dynamic. And the next thing we're going to talk about is, let's say we want to have kind of like a side view physics simulation with gravity. Gravity is very easy to implement. All we have to do is say world.gravity dot y or x. In most cases we will have y, in most cases it will be a positive number. So you can give it 10, you can change that number to give it stronger or slower or less gravity. And you can see now all the objects respond to that gravity, to that force. In this case, if we want that ball to fall and hit that ground and that ground or that box to be kind of be like a ground, we'd want to keep that static, and that will not be affected by gravity. Um, Now you can see this ball kind of lands with a thud, so you can also change the bounciness of a sprite by just saying affecting a property called bounciness. So ball sprite bounciness equals, and then I'll say 1, but that's again something you can play around with. 1 will kind of return it to the same spot again and again, or you could do something like 0.75, where it gets a little bit, bounces a little bit smaller each time. That's still pretty bouncy. So it's another property that you can play around with. So let's say we wanted to take this and kind of make it into a little bit of an interactive experience or game or some sort of challenge for the player. Let's say we wanted to make it so that make this box that can be controlled. So the box paddle could be like a paddle that could be controlled by the player. In that case, we're going to want it to be kinematic, because if we want it to be a paddle, let's just start by making it rotate left and right with A and D. So if we wanted to do that, we have to do that again. Whenever we're using input and respond to input, we have to do that in draw. And if we want to respond to the keyboard, we can say KB dot pressing if we want it to hold down and continue to rotate. And then I'll say A, and then I can do, well, I'm at it, else if kb.pressing, and put D in here. And then for A, we can say box sprite, if we want to rotate it, dot rotation equals, well, rotation plus a number, or we can just, the shortcut is say plus equals 2. And then the D key, we can do the other way, negative. So now we still have that kind of Y and that kind of that rotation in there. Sorry, the velocity for here. So let's take that out. But it is working kind of how we'd want this to work in terms of being able to control this a little bit. Actually, I think might be a little bit more intuitive if these were backwards. If these were switched. Okay. Yeah. So now, we can control this a little bit, but it would be nice maybe if this was tracking to the mouse, if this was more like a paddle that was tracking to the mouse. And we can do that pretty easily a number of ways. But there is this move towards function. So kind of like have we can make it so the box sprite moves towards the mouse position. And that takes in an X and a Y or like a X and or location. So we can just pass in mouse here. And then an optional second parameter, we can say how fast it tracks. So now we kind of have this this paddle here that we can kind of use, and we can also, if we click, we can rotate. Whoop. And we might want to play with this bounciness, and if we wanted to actually make this into a game, whoops, still a little bit too much. There we go. And again, you can use the left and the right. And you can play with gravity, play with bounciness. Some of these physics values, playing with physics values can be, very sensitive when you mess with them. But yeah, this could be this basic start of kind of like a paddle-like game.